Okay, so today we're going to just review scientific notation. So a couple things. All right, first off, I'm going to call it the coefficient, but it's the number in front of the power of 10. We're going to have a coefficient, and we talked about yesterday how the big criteria needs to be between 1 and 10. So that's rule number 1, is that your coefficient needs to be between 1 and 10. So you can't have 12.7. It has to be 1.27, okay? So you can have it exactly 1, but it can't be 2 digits in front of the decimal, so 10's too much. So that's the number 1. And then we have times 10 to some power, okay? And what we're going to do is explore that n for a moment. So if we have an n that is positive, that represents what we consider a very large number. And what a very large number means is that it starts with numbers. I know that sounds silly, but that's really what it's all about. If n is negative, we call that a very small number. And that starts with a decimal. Now, you may see a 0 first and then the decimal, but remember 0 counts for nothing, so you can remove it and you would see a decimal point. Okay, so that would be the first thing. So let me give you an example of each. So if we have 3,200, we could write it in scientific notation as 3.2 times 10 to the third. Why 3? Well, it took me 1, 2, 3 spots to get the decimal in the correct spot. Because the first number I saw was a number, not a decimal, first thing I saw was a number, that's what told me the exponent was going to be positive. Okay. This one, let's see, we have 0.0003, no, let's do it 0.0032. Okay. This number would be 3.2 times 10 to the negative third. Okay, and why? Because it took me 1, 2, 3 moves to get the decimal in the right location, and the negative comes from the fact that the first thing I saw in that number was a decimal point. Okay, so that's the difference between the two, how we can have a positive exponent versus a negative exponent. Okay. All right. All right, let's see, what else? So when we're multiplying, in scientific notation, and notice how much easier it is to do the math in scientific notation instead of expanding it out, having a whole bunch of zeros in different places, doing the math, and then moving the decimal point to get rid of all the zeros. That's a waste of time. That's why scientific notation is very streamlined, the process. And again, it was developed by scientists in order to deal with the reality of distance from here to, planets versus the diameter of atoms. I mean, they have such diverse numbers to contend with, they wanted to make the math as simple as possible. So multiplying in scientific notation, so much simpler. And what you're going to do is multiply what we call the coefficients. Now when you do that, some of the times you realize that the number you got didn't meet scientific notation standards. So you may have to adjust the coefficient to be in scientific notation. So you may have to create scientific notation with the coefficient. We haven't even dealt with exponents at this point, right? We've just focused in on the coefficient. So you may have to do some adjustment. And then you're going to add, because it's a multiplication problem, the exponents on the power of 10. Okay? So we're just doing the same thing we were doing with monomials, but we have two different things we have to pay attention to. We have regular numbers, and we've got exponents to deal with. Okay? How does this change when it's dividing? Well, it's just different operations, same process. And if you notice from the examples, they did all the math they could do, then they went back and looked at the coefficient if they needed to adjust it. Your choice is you can do it that way, which is those two examples that were step by step, or you could do it this way, where you could adjust after multiplying the coefficients and then do your powers of 10. So it's really kind of your decision, the order that you do the steps. So in this one, you're going to divide the coefficients. And again, you may need to adjust the coefficient to be in scientific notation. And then you're going to subtract, because it's a division problem, the exponents in the power of 10. Okay? So what I want to do is see if I can come up with a really good example where I'm going to show you some strategies that makes the math not so horribly long. All right, so what I'm going to do is give you a combo problem, and I'm going to show you how this doesn't always work. In fact, the example that you guys gave me I wasn't able to do anything, but this one does have a little help on it. So we've got 5 times 10 to the negative third. We're going to multiply that by 3.26 times 10 to the negative fourth. We're going to divide that whole thing by 4 times 10 squared. So what I'm going to do is pull out all the coefficients and put them together. So I have a 5. Now notice how they're using an old-fashioned multiplication symbol. That's because we're dealing with decimals, and they don't want you to think that the dot means a decimal versus multiplication. So they're going to use that old-fashioned. It's very rare when I see it written with decimals. Or with the dot for multiplication. Did anyone watch the Khan Academy videos? Okay. I think he used the dot. He did use the dot for multiplication in that. So it was a little off-putting to see that. So you have to kind of watch out. So here we're going to have these guys. Okay. And we've got this. And then times 10. And we have negative 3 plus negative 4 because they're being multiplied. And then I'm going to subtract the denominator, which is 2, because I'm doing division. So here's something that you can do because of what's happening in the numerator. Notice that you have 3.26 and 4. 3.26 and 4 are even. So I can divide out a factor of 2 from each of them. So 2 goes into 3 once with 1 left over. 2 goes into 12 6 times evenly. And 2 goes into 6 3 times. Now, I'm allowed to do that because I have products or quotient. And so I can divide any factor in a denominator with any factor in the numerator if all I've got going on is multiplying in the numerator, okay? So what I'm doing is making my numbers a little simpler to deal with. Now, 2 can't go into 1.63, can't go into 5, so at this point I'm going to stop. But it's easier for me to divide by 2's than it is by 4's. Not to say that I can't do it, but for some people. And sometimes in these problems, the number in the denominator goes completely into the number in the numerator. And it makes it much simpler to deal with. So let's multiply on the top. And we get 5 times 3 is 15. 5 times 6 is 30 plus 1 is 31. 5 times 1 is 5 plus 3 is 8. There needs to be 2 digits after the decimal point. And then I'm going to divide by 2. And over here, I get negative 3 plus negative 4 is negative 7, and I still have the negative 2. Now I'm going to divide 2 into 8.15. Now, I'm used to doing short division, and so I'm doing a lot of the steps in my head. If you feel more comfortable doing long division, you just do it off to the side of the problem. So with short division, the decimal point's going to stay where it's at. 2 goes into 8 4 times evenly. 2 cannot go into 1, so I have to hold the place. So now I've got 2 going into 15, which is going to go in 7 times. Now remember, because this comes after the decimal point, I can add zeros, as many as I need to, one at a time. And with that leftover one, 2 is going to go into 10 5 times. These add up to give me negative 9. My coefficient is written in standard form because it's between 1 and 10, and my problem is done. I don't have to do anything else. Okay? Let's do one where we would have to make an adjustment, just so that we all are understanding how to do that. Let's see. Let's do just a simple problem. 2.7 times 10 to the 12th divided by 9 times 10 to the 12th. Okay? Yeah. So what I'm going to get is 2.7 divided by 9 times 10 to the 12 take away 12. So off to the side, I'm going to do my division, and I get 9 goes into 27 3 times. So I get 0.3 times 10 to the 0 power. But the issue is my coefficient doesn't meet standard scientific notation. It's not between 1 and 10. So what kind of number would I consider 0.3 to be? Very small, very large. Yeah, you see a decimal first. So that tells me when I rewrite this by moving the decimal point over one spot, it's going to give me a negative exponent. So just this portion is now rewritten as 3 times 10 to the negative first. Now, interestingly enough, I still have a 10 to the 0 power over there. But what happens when I take 10 to the negative first and multiply it by 10 to the 0? What do I get? I get 10 to the negative first. So my answer works out to be 3, or 3.0, times 10 to the negative first. Okay? So that's what I mean by making adjustments. Sometimes you'll need to make adjustments. Okay? And that's it.